Have you ever stopped to wonder how we manage to feed a world of literally billions of people? Well, a huge part of the answer is hiding in plain sight, inside something incredibly small but unbelievably powerful, a seed. And not just any seed. We're talking about a hybrid seed. Today, we're going to unlock the science behind this agricultural revolution. It's a story of some really clever biology and meticulous design that happens long before a single plant ever even breaks the soil. And this is where our story really kicks off. 15 to 20%. That number right there, that's the potential yield increase a farmer can get just by switching to high-quality hybrid seeds. Now, to give you an idea of what that means, in a world where every single harvest counts, a boost like that isn't just a small improvement, it's a massive, game-changing leap forward. So how is that even possible? I mean, how can one tiny little seed be so much more productive than another? The answer isn't magic, but you know what? It's pretty close. It's a fascinating mix of genetics, really careful planning, and some very, very clever biology. So let's break it down. To really get the why behind all this, we have to zoom out and look at the big picture for a second. Simply meeting the food demand for our ever-growing global population is one of the biggest challenges of our time. It means we have to constantly be innovating to get more out of every single acre of land. You know, there's a saying that really just hits the nail on the head. Good quality seed is the most critical input for enhancing food productivity. And it's so true. I mean, everything from the bread on your table to the feed for livestock, it all traces back to that one initial seed. It truly is the starting point for our entire food system. And that brings us to the secret ingredient. The power behind these amazing hybrid seeds comes from a really remarkable natural phenomenon. It's kind of like a biological superpower that plant breeders have learned to harness. Okay, so the official scientific term is heterosis, but you'll almost always hear it called hybrid vigor. The simplest way to think about it is the best of both worlds. When you cross two very carefully chosen genetically different parent plants, their offspring, that's the hybrid, it can end up being stronger, bigger, or way more productive than either of its parents. Let's look at a real-world example to make this super clear. So imagine we have parent A, our female plant. We've picked her because she has fantastic pest resistance and produces a ton of seeds. Then, over here, we have parent B, the male. He's chosen for his strong stalk that won't fall over in the wind, and because he's great at producing pollen. Now, when you cross them, you get the F1 hybrid there in the middle. And here's the cool part. It doesn't just average out their traits. It can actually inherit the best from both, resulting in this superior plant with higher yields, better uniformity, and enhanced resistance. It is a genuine upgrade. So the science totally makes sense. But how do you actually do this on a massive commercial scale? This isn't something that just happens by accident in a field. It's a highly specialized process that requires a very precise, step-by-step playbook. The whole operation really boils down to this four-step process. First, breeders spend years, sometimes decades, developing those pure parent lines. Then comes the most critical, most delicate step, controlling pollination to make absolutely sure you get the right cross. After that, it's all about managing the field for perfect growth. And then finally, carefully harvesting and processing only those new, superior F1 hybrid seeds. To understand pollination control, think of it this way. Pretty much every flower has male parts that make pollen and female parts that receive it to create a seed. So to create a hybrid, you have to play matchmaker. You have to control the whole process so that pollen from your chosen father plant is the only pollen that gets to the mother plant. And here it is, the core challenge of the whole operation. Most plants can pollinate themselves. For hybrid production, that is a total disaster. If the mother plant pollinates itself, you don't get a superior hybrid, you just get, well, more of the mother plant. So the entire process really hinges on finding a way to stop that self-pollination from happening. Well, growers have three main strategies to solve this puzzle. The most direct one is called hand emasculation, which is literally going plant by plant and removing the male pollen-producing parts. A more elegant solution is using something called male sterility, where the mother plant is bred so it's naturally unable to produce its own pollen. And finally, some plants have this cool built-in genetic system called self-incompatibility, which stops self-pollination in its tracks, and breeders can definitely take advantage of that too. A classic example that you might have actually seen is maize or corn. You know that tassel thing at the very top of a corn stalk? That's the male flower, and it showers pollen down onto the silks of the ear below. So to create hybrid corn, crews literally have to walk the fields and pull the tassels off of all the plants in the designated female rows. This detasseling ensures that every single kernel on those ears can only be pollinated by the wind-blown pollen coming from the male rows. So as you can probably imagine, a process this delicate demands an incredible level of precision. The goal here is to produce seed that is as genetically pure as humanly possible, which means that quality control is, well, it's absolutely everything. A huge part of that quality control is the field layout itself. You don't just plant half female and half male. It's all done in these super specific ratios, like maybe 4 rows of the female parent for every 1 row of the male. This precise arrangement makes sure there's enough pollen from that smaller number of male plants to effectively fertilize all the surrounding female plants. And that quality control goes way beyond just the planting ratios. These production fields have to be isolated by a really significant distance to prevent any stray pollen from some other field from drifting in. They have to be perfectly clean of any volunteer plants that might have just sprouted up from a previous crop. And timing is crucial. You have to sync it up so the male and female parents flower at the exact same time. On top of all that, workers constantly patrol the fields, removing any off-type plants in a process called rouging. Now, this technology has been a cornerstone of agriculture for decades, but it is not standing still. Science is constantly making this whole process faster, more precise, and even more powerful, and it's shaping the next generation of our food production. Believe it or not, the next generation of hybrid breeding is already here. Instead of spending years just watching plant traits in a field, we can now use genomics to look directly at a plant's DNA, which dramatically speeds up how we select the ideal parents. We're also seeing these new biotechnological systems that act like genetic on-off switches, making pollination control way more efficient and reliable than manual labor, and they bypass a lot of the old traditional complications. It all comes back to the seed. From harnessing a simple biological phenomenon to deploying advanced genomics, the quest to create the perfect seed just keeps going. And it leaves us with a pretty fascinating question. As the challenges of tomorrow emerge, how will we continue to unlock nature's code to feed our future?